Thank you, everyone. Good morning. As the introduction, so my name is Javier Campos. I'm the head of the Experian Data Labs for UK and EMEA, and I will explain what they are. So just a bit of a disclaimer. If anyone attended the Chief Data Officer Analytical meeting, which was here as well this week, I did a similar presentation, but this one focuses on financial services. The other one was generic, how to do AI in any industry. So there will be a couple of slides repeated, but this one really goes into what it takes to do AI successful on our industry. So the first one is why can I talk about this? Well, it's a brief introduction of what the data labs are. Hopefully everyone in the industry knows what Experian is. We are started as a credit reference agency, a CRA, but we now, of course, have quite a lot of diversify. We also have a direct-to-consumer business in some countries like US, UK, and Brazil. And so within Experian, and one of the things we do is we do have a lot of data. We call something about the data per capita. And in some countries like the US or the UK, in the US, for example, we have more than 200 data points per capita or per person. That's quite a lot of information, not just credit risk. We also hold quite a lot of other databases. Of course, some of these data sets are all highly regulated. So, and this is what I suffer every day. So you can't just do whatever you want, but there is quite a lot of data. We also have data both for consumers and SMEs. So within Experian, the data labs, we are like the internal R&D. So we are a relatively small team. We have 4 hubs around the world, one in San Diego, which started in 2010. My hub is in London. We cover UK and EMEA. There's another one in Sao Paulo and another one in Singapore. We're about very highly specialized data scientists, but ours are a bit on the research side of things. And I explain a minute the difference. And we basically specialize on, we are an applied research, so we don't do research on research. And what we do is we just explore the industry, the scientific community. We attend all the different conferences and so on. And when we see we can apply something from that is coming out of the field to actually solve industry problems, that's what we do. And then what we do is we partner with either clients or sometimes direct to consumer, and we create, that's how we innovate. And in that process, as I said, we actually do pretty much every new technology, but we have been doing quite a lot of AI since quite early days. The other thing, you can see there, we do have quite a lot of published thought leadership. We appear regularly in Harvard Business Review, Forbes. We've been quite a few books. You will see there, and that was my lab. We did a project for the NHS during COVID, so we actually end up on an interview on the BBC, which probably one of the best moments. We just worked with NHS in Nottingham, which is where Experian is based. And what we did is we actually did a model which was highly customized and localized for the hospital in Nottingham to understand the spread and predict how COVID was spreading. And our model actually was quite a bit more accurate than the national one that the government has. It was all also about the data. I won't talk a lot about the model, but ours, one of the problems, and you will see across the entire world, most of the governments got quite wrong the spread of the disease. Many reasons, but one of them is a lot of the models take the infections as an input. The problem with infections is it depends on how you test. And the problem is all governments around the world, pretty much, they keep changing how they test it. Even if they always test a lot or less, but they didn't change, that would be okay. You could still take the model and the model to predict how COVID was spreading would be okay. But because they kept changing, now we're going to test only key workers. Now we test everyone. Now we test who has symptoms. All that change meant that you couldn't use infection. They were absolutely quite a useless data point. That's why a lot of these models were really bad, predicting and very inaccurate. We did something else. So our model, we actually use AI, but I think as well as the modeling, the key there is rather than using infections, which we realized was quite useless, we saw a better proxies to detect how the disease was spreading is the number of calls to 111 and the mobility data that both Apple and Google, they published during the pandemic. Taking those things, our model could predict quite accurately and locally how the disease was going to spread. So Nottingham was one of the few hospitals in the UK that they didn't have to declare any major incidents because they knew in advance, or we actually was quite accurate how the disease was going, to the point we predicted a bit earlier where the big wave was going to come back in Christmas and in January, and so on. But anyway, that's an example of what we do. So just trying to go. So the other thing, which there is a lot of stuff, as well as Experian, I've been part of a group by the Bank of England of the FCA. It's called the Artificial Intelligence Private Public Forum. It was set up in 2020, and the terms, which is all published on the websites, both of the Bank of England and the FCA, it was a group to say, look, how we can actually encourage the industry to take artificial intelligence in the right way. So there were 21 members selected from all these companies like the Microsoft, Google, Alan Turing Institute, and of course Experian, which is me. And we just been working during nearly a year and a half, and just published the final paper, which I strongly recommend. It's also on the website, so please, if you haven't read it, download it, because it contains. I'm going to talk a little bit about the output of the document, but it's actually a really good document that contains all the recommendations how to do AI on many areas. But we're going to touch on some of the key learnings from that document. Sorry. So the first one, why AI is important, and the challenge with one of these groups is, I'm sure some of you will be really, really experienced and or might already have some AI implemented, some others are still looking. So because the diversity of the audience, I have to include that one, which if you know that, apologies, but for the rest, it might be useful. I think that the first one, why AI is important. Many people say, well, it's just another technology. Why would I worry? IT changes, and there are all the time these different wave of new things. AI is another one. Well, here it's not quite like that. AI is quite transformational. It's been sort of identified like similar to electricity. And electricity changed the society at the beginning of the century because allowed to decentralize power. Before electricity, if you wanted to have power, you have to go close to where the electricity was generated, and more importantly, and those factories were actually where the mines, where the raw material is. And if you look at the map of 18th century Britain, for example, before the Industrial Revolution, you will see a lot of the industrial areas are very close to the mines because of that. Electricity came, changed society. AI is going to do the same. Why? Because AI allowed to decentralize the human decisions. And it's going to be little by little, by the way. I'm not saying that every single human decision is going to be decentralized in day one, but as AI gets better and better, we can decentralize more human decision. That little decentralization have massive changes pretty much in all society. The way we learn and our children, the way we are actually in healthcare as well, the way we operate, all our processes, insurance, financial. So that's why it's very important. It's not just yet another technology. This one is special. So if the AI is so, it's got so much potential, why so many, still very few models made it to production? So here you can actually, I pick, these are the recent one from Pricewaterhouse and McKinsey, but pretty much every company, every big consultancy, Gartner, Forrester, consistently they do surveys and everyone is the same. People want to do AI, very few really take advantage of that. I put over there is an industry, there are two axes, one with the industries and then the capabilities of AI, whether it's computer vision or whatever, and you will see that for financial services is a bit better in terms of other industries, but still some of the technologies, and the circle means how many of the respondents say that they're using that technology is not still quite there. This thing from Pricewaterhouse is the same thing. If you then want to focus more on financial services, that is a report and a survey that at the beginning of our project with the AIPP, the Bank of England and FCA, we did a survey which I'm pretty sure some of you might have answered. It was back in a bit before in 2019, at the end of 2019, saying how many AI do you have in your systems? And that's the answers we got. This is how mature you are. You actually have things in production, or you're doing some experimentation. And you will see there the colors, the darker it is, the more it is, and the lighter, the less. And when you see the picture is the most advanced, where there is the most AI is in risk management and customer engagement, especially marketing. But then in other areas, still a lot of stuff to do. It also depends, this is the entire financial industry, so not just lenders, but pretty much payments and everything. So I think here the key message is, when you look at some of these processes, there is so much to do. AI can really help in quite a lot of those things, and we're still very early days. So there is still a lot of stuff to do. So why we're struggling with that? So if you look at on one side, and actually a lot of these things can be said about any innovation, any new change. It's not just AI, but whenever you have something that can improve your method, and in this case, AI, the other thing to mention is normally regulators are very wary of new technologies. And if, for example, the Bank of England, if you look at some of the papers they're producing in terms of the, let's say, blockchain or cryptocurrencies, they're not very keen, and they're a bit cautious. For AI, is actually the other way around. They're very keen for the industry to take it. Why? Because AI can, and is not common, is a true win-win. It's better for the customers, and it's also better for the firms. For the customers, can be much more personalized, one-to-one, and for the bank means, depending on where you are in the financial industry, you can actually get better profit. So it's truly a win-win. That's what the regulators really want, the whole room, the whole industry to do more AI. So there are benefits. What are the downsides? And these are, as I said, not specific to AI. It's pretty much, for me, the main thing, and I've been doing innovation in many big corporations during my career, in pretty much all the top companies. I was also in Accenture for 10 years, so I've seen quite a lot. The main thing comes with there is an imbalanced risk-reward. Whenever you implement something, you need to get the buy-in of the middle management, the people that operate the business. And for them, there is always going to be, and it's not balanced. And that needs to be fixed, by the way. And the way to fix it is governance, which I'm going to talk. But if you don't realize that, you will fail, whatever you try to do. And it doesn't, these apply, as I said, not just AI, any innovation. So what is that imbalance? The imbalance is if you do something which is amazing, you might get a big bonus, you might get a promotion, but that's one thing. But if you big change fail, you will likely be fired. So effectively, the two things are really, really different. And most people, because they are conservative, especially when they got in the long careers, they actually rather not try rather than risk to be fired. That's why this unbalanced risk, unless you fix it and address it, and there are ways to do it, most of your innovation will fail to be implemented. And this is the point, even if it can actually work. I'm going to accelerate a little bit. So why companies, if you look at all the different diagrams, there's, if you remember from the other graphic, like only 7%, 10% of the models end up in production. Why is that? There are three main areas which, you should, just to remember. The first one is make sure you have the right team. Second is about the data and technology. There is quite a lot of misconception. And finally, for me, governance is absolutely clear. So in the right team, and I'll talk a little bit about the, when people do data science, and I've seen doing both, badly done. So the first one is you need to have the right balance team, meaning on one hand, and you probably see a bit of a fan of Star Trek, but you will see there you need what McKinsey call a business translator, which is someone who can really translate the business need into sort of data science speak. Then you need, of course, the data scientist. And very, very important, you need someone from IT in the team doing the model to make sure one thing is, okay, is there a signal on the model? Is that going to work? But start thinking about how I'm going to put it in production. A lot of the things I see about the companies, they made the mistakes and they don't include. So for example, many companies think, oh, I'm going to hire this amazing data science, which I pay him a lot, is a unicorn, and he's going to do everything. A data science on his own, he will most likely fail because doesn't understand how to scale things, doesn't talk to the IT people, so I think you need to have a bit of both. The other thing, which for some type of project, you also have to have creative people. This depends on what you're trying to do. Some analytical model, you don't need that, but when you need it. And for me is make sure you have all the right skills in the same team. And as I said, the key there is people forget about the IT. They get the data scientists, they do the models, and then they expect this to fly. This eventually will go wrong. So make sure you have the right thing. The second one is sort of infrastructure, technology tools. This is how a real ML works. This is from a Google paper. It's over there, the technical depth. And effectively, when you look at the AI or the ML, it's just a tiny bit. The rest is massive engineering, which, by the way, all this is technical depth. And I explain in a minute what that is, which is necessary for feed to the model the right data so the model can do the right prediction. If you don't have the things around, the AI won't work. That's why when if you think about it, the data, and this is, many people don't realize, and they say, well, the data science, the data science will do the one in the black. The others, you need engineering and IT, and you need the scale, and that's why you have to have both of them. The other thing is, and this is very important, why most of the AI look like that, which, I talk about technical debt, meaning you're doing a legacy. Because the current IT systems are not set up to do AI. This is a claim, a bold statement, and probably the IT people might not like me, but because a lot of the IT, and the software engineer, and I have a slide at the end, has evolved quite a lot over since the 60s, 70s. They've done a process which AI is now going, but one of the main points or principle of IT is all the things can be decomposed in independent systems, and there are like blocks. If you think about it, the microservices, the testing, a lot of any IT system infrastructure is based on that principle. AI actually is not decomposable. Why? Because the output of one system. So because a lot of the AI, what it's going to do is going to adapt to the data. So the output of one system, it will change the input of another system. So if you have a set of AI systems all connected, if one is weaker, the other one will compensate. And they're not independent. And if you treat them as independent, you will get into trouble. Google knows this very well when they design the way search works without going into detail. So I think here, and this is what I put is little bear, which is a co-evolution. When people say, what came first in nature, the bear or that flower is got a specific area to protect the pollen? The answer is they both could co-evolve. And this is the same with the IT systems. Unless you think about this, if you try to do ML just on an IT, it's just an API service and I don't worry about the rest, this might end up in a bad place. So talking a little bit about the specific for the financial industry, this is coming from the PDF, from the public report I mentioned. So here is as I said, you need to see it's all like a continuum between the data and the model. At the moment, the way both the governance and actually a lot of the IT is designed is like one way. So I do something, deploy, and I forget until in 2 years when I review it again. With AI, you cannot do that. If you do that, you're going to get into trouble. And that's why you will see a lot of diagrams, and we put a lot of points in the PDF to really emphasize that. The data and the model, they continuously you have to be iterating all the time. You do a model, then you deploy, but then you very quickly have to monitor, and very likely you will have to refresh it. For example, credit risk model, which is an area we've done quite a lot. If you look at the moment, the traditional ones, they actually tend to last between 2 or 3 years in production. It takes between 9 and 18 months, from the time somebody said, oh, I want to do a new credit risk model for a new credit card. it takes a lot to get the data, the retros, contact the credit agencies, do all the simulations, get all the different governance. So it's a very lengthy process. If you want to do AI, you cannot keep those things because if you create an AI model in credit risk, you deploy it and you leave it 3 years in production. Well, I can tell you, no good things will happen. So you need to change and monitor continuously. And for example, on credit risk, and as an example, you might have to refresh it every three or 4 months. So it's quite a different one, but it's also more accurate. And again, people say, oh, well, the current ones, we don't want to touch it. Well, the current ones are not accurate. And you leave them three years, and they make mistakes. They're actually harming consumers. They are approving people that they shouldn't, and they're rejecting people they shouldn't. So in terms of the governance, you probably see most of you will have some sort of like the 3 lines of defense. This is what the regulators recommend. For AI there are specific things which I think the key there is you have to have, if you want to really push AI and do AI, you have to have some sort of centralized section. We debated this during the group for ages. Do we keep it decentralized or not? Actually, I think you need someone like and then in the next one, you do need, and here is what we say, look, you need someone like a chief AI officer. Sometimes this role can be done by the chief data officer, but they have to have the skills, or the head of model risk management. But you need someone to set in the standards, the different what you should do in all the AI, and then this cascades through all your lines of defense. So of course, the first line of defense, we have responsibilities. So here, for example, I listed like 2 or 3 key areas. All this is a copy and paste from the document, by the way, so you could actually see it. But I think the key message here is if you want to do AI, you need to, for me, the main thing you should, and I'm going to summarize very quickly and running a bit late. At the end of the day, you will see that in the 3 takeaways, well, actually, I'll do them in a minute, but governance is very, very important. When projects don't really work, the government is not set up correctly. And I've seen many mistakes, like let the data science completely on its own and they do their own thing. That doesn't end up well. They might do models, amazing models, but those models will never get production in a successful and safe way. And it can actually get you in trouble. One of the things as well as I talk about the data infrastructure, a data-driven infrastructure rather than an IT-driven, when data is the first. And for me, this is also very important. You need to have, to do this, what I mentioned about doing monitoring and deploying models quite quickly, you cannot have what you have now. To do it, it will be very painful. You have to do, it will be painful, in some cases impossible. So the key there is to have a ML off, or at the moment, I think this is changing all the time, and I think Gartner talk about model operations rather than ML. The point here is you need to have some sort of infrastructure and the operations so you can monitor and deploy things in a continuous way. One of the last point is, again, when you do the AI, there is quite a lot of myth as well, which we haven't had time about, why people don't want to do AI. It's a black box, might be more biased, whatever. I think the point there is you need to, for me, if we want to do AI everywhere, not just in the financial industry, but in other services, we need to make sure we trust it. And for the trusting, actually, one of the key things is about the explaining, making sure we understand why AI made the decisions it does, and then we can explain it to human. And in many cases, the AI might actually make better decisions than us. So I think we need to a bit of a hybrid method in some cases. So one of the things I put there, and this is acronym, is fairness, accountability, customer, transparency, and safety, is any AI model in the future will or might specify that. And I believe, I'm pretty sure the regulators will go into that direction. So for example, and the example is in the food industry, if you, believe it or not, at the beginning of the century, people could sell cans and they didn't have to put anything what it was inside there. Of course, there were a few cases where people were poisoned for many things. So eventually, and it took them decades for the regulator, and it wasn't until the 1950s when and especially in the US, the FDA make compulsory the use of the labels, which, by the way, this is quite controversial, and still the food industry is lobbying not to put the right, and there is always a tension there, but the regulator is making sure there is transparency. So consumers, when they get up food, can they do? The same is going to happen with AI. And for me, one of the things, in 10, 20 years' time, we will look at what happened just before the last 5, 10 years, and people will say, we were really actually, it's like now, for example, when I tell you, look, at the beginning of the century, you could sell food and nobody will have to put the ingredients. You say, that's crazy, stupid. Yes, it is. The same is going to happen with AI. And actually, if you think about it, people will say, how could you have big social networks doing a lot of stuff with AI and nobody actually knowing what it does? Part of the challenges we have, and is another fascinating, which I don't have time to go into, but if you look at what's happening on the social network, in many countries, people have got more polarized over the last few years. There is a bit controversy why that happened, but potentially social networks might have a role to play there. The key question is, we have led, and actually it matters a lot. What you see in your phone eventually is going to make public opinion. We have led a lot of big companies doing a lot of stuff. They're not transparent. We don't even know what they've done. And these have consequences. So I think, as I said, in 10, 20 years, people will say, why did we let, like the beginning of the century, the food with it there? So very quickly, in the last 5 minutes, if you're going to take 3 takeaways, I think the first one, which maybe 4, is please download the document. It's not, we make it, actually, that's what it took longer. We make an effort to not publish the typical 400 pages we know nobody's going to read. So it's only it's about 60 pages, something like that. But it's all set up in best practices. It's also sections for the firms, for the consumer, for the regulator. So if you can take a look at the document. After that, 3 there. The first one is where we are on the AI journey. And again, I don't know if I'm sure anyone is old enough like me to remember this page. That was the first mosaic, back in the 90s when actually the internet could only be accessed if you were in a university in one of the backbone of the internet and you have to connect. I mean, it was fascinating the way it worked, but I think that was one of the first versions. So I think in AI we are like that. People sometimes might tell you, which sometimes vendors, sometimes for many reasons, like, oh, well, AI is all done. No, it's not. We are really, really scratching the surface. There are many types of algorithms. We literally just exploit one of them, which is the whole deep learning. And again, now there is also a controversy whether we hit a wall or not. But I think the point is, we haven't hit a wall. There is a lot of stuff really coming out there. And so it's going to change a lot. So don't think of AI as what it is now. That's going to evolve and it's going to mature, which does also have implications. Can you today buy a platform that is going to do your AI forever? No, you cannot, because we don't even know the AI in 5 or 10 years, how it's going to look like. There is quite a lot of, and actually there is, in the last few years, there's been all about deep learning, most of the research, but there are things now coming up. One of the things, again, if someone is interested, I keep quite up to date. I think for me the most interesting is called multi-mode learning. And what it's trying to do is really fascinating area of research. One of the problems we have today with AI and deep learning, you need a lot of data to train a deep learning. They're very, very accurate and very good, but you need an enormous amount of data. And some of that data also have to be labeled by a human. So it's expensive, it's slow. What we're trying to do with some of the new research is, okay, forget about that. Yet we can do that and it works. Why don't we try to copy how babies, human babies learn? A baby, you let them there and within few months of life can negotiate an environment like that. The best robot in Boston Dynamics will take literally billions of data points to do the same. And a baby can do that in literally a few months. What is going on different there? So the point is about all multi-mode learning, that taking input from, so the way we do it, and there are really good experiments where A machine can take a video, take an audio, take different points like a baby do with the senses, and actually identify, for example, there was a very good paper published recently, they could detect a guitar, but they didn't know what is a guitar, but they knew whenever that thing in an image happened with that sound, without that, that is something. And then someone has to label, which, by the way, babies learn like that. They do objects mentally, and then somebody tells them where they are. So this is a very good area, and it will change a lot, but this is very early days, by the way. When I just tell you that will be 5 years. So very quickly, the last 2 points, and I'll finish. So then the second one is about the fairness and governance. The thing about AI can do mistakes, of course. Things are not perfect, but what is different from human is when AI makes mistakes, they make them quick and at scale. So we need to be very careful. That's the movie Spider-Man. With great power comes great responsibility. We need to make sure we have the right governance. We need to check things like fairness, transparency, and so on. And the last one, and with this, I close. I think we're out of time. And of course, AI needs data. So data. If you really have to have the right data for the AI to work, although I will say the way to do it is focus on what is the business case you need to do, and then worry what data do you need. People starting the other way around saying, I'm going to put all my data in a data lake and I'm going to spend billions and 10 years doing that. That might not be the best way to do it. Why? Because the data changes. And if you remember the comment I made with the COVID, actually the main problem with COVID is people started the wrong way, started with the data and the wrong data, versus if you started with the problem, which is I need to specify what's the best way, I need to predict what is how the COVID is spreading, you will do the different thing here. So the message is you need to have the right data, but not necessarily start with the data first, just whenever you do it is there. So with this, I'll finish. I think I'm over another. So thank you very much.